Hello, you're welcome to SK Price International College. If you have not yet subscribed to this channel, kindly subscribe to the channel, like the video, and share to your friends in other schools. Today is another interesting day, and we would like to continue with our topic hybridization. There are some topics under this which we need to understand. So if you have not watched my previous video, kindly watch and get back to me. We are still on the type of hybridization, the simple way to know the type of hybridization in a molecule. There are so many simple ways you can use to know the exact type of hybridization in a molecule. In my previous video, we were able to give example like water H2O. We were able to come out with a very simple trick to know the type of hybridization in water, and that of methane. So today, let's continue with the next molecule. Let's look at a molecule like NH3. This molecule is very common, ammonia. If you want to determine the type of hybridization in ammonia, the first thing you need to do, you can go by the normal procedure, just like I taught, or you use a very simple trick to know the type of hybridization. So let's look at the central atom. The central atom here is nitrogen, and nitrogen belongs to group 17 on the periodic table. It has atomic number 7. So if you want to write a configuration, it's going to 1s2, 2s2, then 2p, 3 plus 2, 5 plus 2, 7. So this will be the configuration for ammonia. However, with this ammonia, we have said several times that we don't use the core electrons in chemical bonding. We only use the valence electrons. So we can see clearly that this ammonia will have 5 electrons which will undergo bonding. 5 electrons at the outermost shell, this 5. So with this, this 5 will have to form 3 covalent bonds with the hydrogen. So we have NH3. So let's look at the first one. This hydrogen will pick this. The second one will pick this, and then the third one picks that. And when this is done, we have 2 other electrons there. Those electrons are called non-bonding electrons. Any electron that do not undergo chemical bonding is called a lone pair, and that is what we call a non-bonding electron. So with this, these 2, they are called lone pairs. So these 2 will form a lone pair. Based on the formula we used in our previous video, we said if you want to know the type of hybridization in a molecule, we use the formula number of sigma bond plus number of lone pair. So the question is, how many sigma bonds are found in ammonia? 1, 2, 3. So we have 3 plus how many lone pairs? We have 1 lone pair. So at the end of the day, we have 4 what? Hybrid orbitals formed. Let's look at the shape to appreciate what we are talking about. So this is my nitrogen. They prefer to stay far away from each other. So we have this. And then there is a lone pair here, like this. So you can see the shape of this. This is the shape of ammonia. It's having a lone pair, and the angles are far away from each other. Because of the lone pair, there will be a repulsion. Now let's look at this. We were able to talk about the various types of hybridization. Whenever you have the number of hybrid orbitals, we said that when you're having 2, then it is linear in shape. Or the type of hybridization is sp hybridization. 3 is sp2, 4 is sp, this is sp2, sp3, 5 is sp3d, 6 is sp3d2, 7 is sp3d3, in that order. So first of all, let's look at the number of hybrid orbitals formed. So we have 1, 2, 3, 3 plus 1, which is 4. So automatically, when you move to the chart, you realize that with 4, The type of hybridization in ammonia is sp3 hybridization. So these are some of the questions we normally ask in exams. You are to explain why ammonia is supposed to have a bond angle of 109.5, but it's not. Explain. In this case, this ammonia too, we can say that we are expecting to, since it's having 4, we are expecting to see a shape like tetrahedral in shape, but it's not having that shape. This is another interesting question. They can ask you to explain why ammonia, although it's expected to have a tetrahedral shape, but it's not. Now, these are some of the reasons. Why is it that this ammonia is not going to be having this type of, although it is sp3 hybridization, the type of hybridization is sp3, but the bond angle is not 109.5. Why? I stated this in a previous video that anytime a molecule has a lone pair, one lone pair is equivalent or is equal to 2.5 in terms of value. So, at normal circumstance, sp3 hybridization molecules are supposed to have a bond angle of 109.5. That is 109.5. But this ammonia has different bond angle. Why? Because this ammonia has a lone pair. So this lone pair will reduce the size or the bond angle. And because it has one lone pair, it is going to reduce that by 2.5. So for you to know the bond angle in ammonia, just subtract 2.5 from 109.5, and that will give us 107. So if you are asked the bond angle of ammonia, is what? 107 and not 109.5. The reason is because ammonia has a lone pair, and this lone pair, a value for this one lone pair is equivalent to 2.5. When we did for water, we realized that water was having 2 lone pairs. So instead of having 109, the 2 lone pairs will be reduced. So we realized that water was having 104.5 because we subtracted 5 from the original value. However, having said this, the shape of this ammonia can also not be tetrahedral in shape because it's having a lone pair. So this is forming what you call a pyramid. So the shape of ammonia is what you call this is a trigonal pyramidal. So the shape of ammonia is not tetrahedral in shape, but rather this ammonia is having a shape we call it is trigonal pyramidal. It's a pyramid and not tetrahedral. So these are some of the things we need to take notice of. Let's look at the next example. If you don't understand anything, comment. Bring your question at the comment section. I'll respond to you. Now, someone will say, what if I have a molecule and it is a radical? It's carrying a charge. How do I know the type of hybridization in that? We can also do that. Let's assume we have CO3 minus 2, like this. Triisocarbonate 4 ion. If I have triisocarbonate 4 ion and I want to know the type of hybridization in this, it's very simple. We still have to consider the central atom. But in this case, you need to be extra vigilant. The carbon is our central atom. We've done several examples. Carbon belongs to group 16. So it's having this 1, 2, 3, 4, 5, 6. Okay. Sorry, it has 4 like this because we are using the valence electrons. So carbon like this. If you want to write a core, it's 2:4. So this is what you are using. 1, 2, 3, 4. Now after writing the 4, because this is a radical carrying a charge, if it is having a minus, which is an anion, you add the number of anions you are seeing to the molecule. If it is addition or it is a cation, then we subtract. What do I mean? What I mean is, because this is CO3 minus 2, we are going to add 2 extra electrons to carbon. So let's add 2 extra electrons to carbon. Why are we adding 2? Because of the charge of this CO3 radical. Having said that, One thing we should also note about this CO3 minus 2 is that for oxygen bonding with this, we have 3 of them. It's very interesting here. We need to understand this very well. This oxygen will always pick 2 of these bonds, because oxygen, there is 1 sigma bond and 1 pi bond in between the bonds. So take note of oxygen. Anytime you are working with oxygen, the side ones, they are having, it picks 2 of the bonds, not 1. It does not form a single bond. It picks 2 of them, 1 sigma and 1 pi. That's for oxygen. So the next one will also, so 1 has been used. Next one will also pick 2. Another one. So oxygen has been used again. This is the second time. Then the third aspect will be used. So what you are seeing here is that this oxygen is picking them by this order. You need to understand this very well. If you understand this very well, to help you, because if you are using a concept and you are using 1, 1, 1, you may not see the number of bonds well. So in this case, the question is, how many sigma bonds are here? Now we said the formula is number of sigma bonds plus number of what? Lone pairs. So in this case, we have 3 sigma bonds. Because 1 is pi bond, you don't consider the pi bond plus the sigma bond. So we have 1 sigma bond here, 1 sigma bond here, another sigma bond here. So in all, we are having 3 sigma bonds. Then how many this thing do we have? Do we have any lone pair? No, we don't have a lone pair. So 0 lone pair. So the answer here is 3. So from the chart, we said that if I have 2, it is sp hybridization. 3 is sp2. So the type of hybridization existing between this is sp2 hybridization. Very, very interesting. Type of hybridization in this is sp2 hybridization. Let me illustrate something for us to see the concept. There are 3 of the oxygens. So one of them will pick a double bond like this. There are lone pairs here. This is the structure of the molecule drawn. So this is the central atom bonded with 3 oxygens. So this is 2, having a double bond. So the type of hybridization in this molecule, the whole thing is drawn like this. Anytime you are drawing a molecule, you bring it into a parenthesis bracket, then you show the charge. So the type of hybridization existing in this is sp2 hybridization. That is how we use the trick to solve that. Let's look at another one example, and I'll give you some examples to try on your own. Let's assume I have iodine chloride. So this is carrying a charge which is plus. Iodine belongs to group 17 on the periodic table. Okay, so if it's belonging to group 17, it will have 7. To have 7 outermost electrons. So let's do that. 1, 2, 3, 4, 5, 6, and 7. But this is having a plus, a charge, which is plus. So you subtract 1 from it. So when you subtract 1, it becomes 6. Now this is also going to form 2 hydrogen and chlorines. This one chlorine, this another chlorine. The rest are going to form lone pairs. 1 lone pair, another lone pair. So with this formula, you can see number of sigma bonds 2 plus number of lone pairs 1, 2, 2. The whole thing will give you 4. So in this, although it's a radical, but we have been able to determine the type of hybridization in this. So from here, we can say that the type of hybridization in this is sp3 hybridization because it's having 4 hybrid habitats. Thank you for watching this video. Subscribe to the channel, like the video, and share. If you have any question, you comment. Thank you. See you in my next video.